Welcome back, chemistry fans and future chemistry fans. Today is day one of AP Chemistry. I'm going to begin, as I will do every day, teaching you a new lesson. Make some progress in an effort to understand a lot about AP Chemistry. We're going to have several videos available to you on the daily agenda. You'll have your notes that you can access, these answers that we're going to go through for our daily topics. We'll have worksheets and some solutions to the questions that we work together in class. We'll go over the homeworks, and so you can have some ideas about how to solve those. And then there is the laboratories as well. So we'll be able to have the experience of the laboratory without actually being in it. If we end up, or you end up being absent, or myself being absent, we can continue on with making progress with our content. So with that said, I think it's time for us just to jump into the content. Let's get started. Let me share my screen with you, and we will go in with day one. Not going to be terribly difficult day for us. It is all about chemistry basics. We start in this first day just getting some expectations about kind of what you're going to do for tests and quizzes. And so we'll try and get you started on the process with these first slides here. If I could figure out how to make him move. All right, so here we go. Topic one, I want you to become familiar with some common formulas. So in the past, what I have done is I have given this exhaustive list of elements, their symbols, compounds, their formulas, polyatomic ions and their formulas, and I said, memorize it. And it's time for you to understand the rigors of AP Chemistry. And then I started to think about how I actually learn. And it's all about me presenting information that I have gone and reviewed. It's all about me making certain that I know the content information. So I go and look it up quite frequently. If I am writing my own paper for grad school, I will go and look up the information. I don't have it memorized. I go and research. And that's what I'm thinking needs to happen for you folks as well. It's that we need to learn how to access the information. Now, that said, the AP Chemistry does not have that format. It is behind the times. And so as we get closer to the AP test, we will have several days, if not weeks, in which we can reacquaint ourselves with this content, and you can start moving towards a process of memorization. But until then, let's become familiar and know how to access the information, where to get it, and how to utilize it. Okay, so with that said, you're going to have a quiz very soon. I will tell you on the calendar where that is going to take place. But what you will be given is half of this column, or a select few of these elements, are going to be listed as their names. You will have to provide their symbols. The other half of it would be I provide the symbols and you provide the names. Now, I'm going to make it timed. So the people who think, well, I'll just look it up on the day of the test, you're going to run out of time. It will be pressure packed and you will have to be familiar with these. And you say that's not fair. And I say, then study and make it fair, because I'm going to allow you to have access to all resources, whatever you want. The people who are familiar know how to look things up, have looked them up prior to the quiz, they're going to be in an advantage. The people who wait, who don't study, they're the ones who are probably going to fall behind. So I'm not encouraging you to not study. What I'm encouraging you to do is study and not worry about the memorization process. All right, so here we go. If we were to look at some of these elements, you would notice that they're all on the periodic table. And most of them have symbols that make sense. Now, there were a couple on that list that don't make sense. And what you are seeing right in front of you right now is a periodic table. This periodic table is the same one that you will get on the AP exam. It does not have the names of the elements. Now, this copy of it does have the names of the elements with it. So some of the elements that you will need to become familiar with, which are not obvious to you, are things that are in probably Latin originally. So like antimony is SB. That doesn't make a whole lot of sense. Right next to it, tin is SN. Their original names were Stanton for tin and stibium for then antimony. So they do make sense whenever we have context with them. Lead was plumbum, so that makes sense with the PB. We have Hg, hydrogenthum, and that would be for mercury. Again, makes sense in hindsight if we understand where that comes from. Sodium was originally natrium, kalium for potassium. So their original names seem to make sense with their symbols. Now, why did they do the disservice and not change it? I don't know. Iron is fermium, copper, cuprum. So some of these, again, you're gonna have to look through the list, which was on the previous section here. You're going to have to look through the previous section of notes to become familiar with this, with the elements and their symbols. If you were to simply walk into the quiz thinking that I will not have to study, it's a poor choice on your part. You will run out of time and you will learn the consequences of your procrastination, of your poor study habits. I will not provide enough time for you to look up the answers. You need to become familiar with some of them, but if you forget them, you can look them up. That's how I want this game played with me, okay? I want to eliminate all need for you to cheat. I want everything to be out front on the table so that you put your best effort forward with me. All right, the next portion of the quiz will be common molecules. And these common molecules, you can see, are things that we have in our everyday life. You've heard of them, such as methane, ammonia. You even know about salt, but maybe you're not comfortable, maybe you're unaware of what their actual formulas, what they're made of, what elements. So I'm going to try and get you acquainted with some of these, and I won't use all of them, but some of these will pop up on a quiz. So again, looking through this, having it familiar, if not memorized, will benefit you. If you think that you can Google them, you will not have enough time. All right. Let's go through this list. Ammonia, you know this because it is used in most all of our household cleaners, such as a Windex, such as your bathroom, ammonia killing, bacteria, mold killing materials. We have water, ammonia NH3 is its formula. Water, H2O. Every stinking one of you should be familiar with that one. Inexcusable if you missed that one. Methane, that is natural gas. If you have that inside your home for heat, its formula CH4. Carbon monoxide, CO, not little o, capital C, capital O. It's two different elements, carbon and oxygen combined together. It's very poisonous to humans. And it is a byproduct of inefficient heating. If there is a combustion that is going on, but it's not hot enough, it will produce carbon monoxide instead of carbon dioxide. Salt, as I previously mentioned, NaCl, sodium and chlorine added together. Now, carbon dioxide, here's one of the second times that we start to see little numbers. That little number means that there are 2 oxygens for every 1 carbon. We are producing this every time we exhale. Octane, boy, how familiar are you with that? That is gasoline, something you took for granted, which now you're becoming quite familiar with the pain of not having proper resources in the country, or of not having adequate access to some of the alternative energy sources. Octane is 8 carbons and 18 hydrogens. We call it gasoline. Notice those numbers on your gasoline pump. Those are the percentages of octane that are inside of that gasoline. The reason why premium costs more is because it has a higher percentage. Now you should probably do the math and realize Well, there's not much of a difference. Why are we paying more for a little bit premium gas? Maybe your gasoline, maybe your car understands it, but I doubt it. Acetone. If you happen to paint your nails, you will know that eventually you have to remove the nail polish. And one of the products that does that is acetone, C3H6O, one oxygen. Unnecessary for us to put a little one beside it. If we write the letter, it's there. Hydrogen peroxide. It's a cleaning solution that we use whenever we have wounds. It tends to sterilize, kill some of the bacteria whenever it's a surface wound. If it's serious, we go into some of the higher grade antibacterial materials. Ethanol. This is your adult beverages. So it is abundant in most of your it is the key ingredient in all of your adult beverages. C2H5OH. Ethane is what it started with, and then they add an OH at the end. And so that's why it's not combined with the other 5 H's. It's trying to distinguish itself, telling you where that H is located, and that makes it an alcohol distinct. Propane, C3H8. You use this if you have any outdoor cooking habits or endeavors around your house. Those tanks are filled with compressed propane. You've heard of ozone. Ozone is oxygen combined 3 times. We have it in abundance in our atmosphere. It protects us from cosmic radiation. Sand. SiO2. Now, some of you are saying, well, that's just seashells that are ground up. You're right, but what are those seashells made up of? And over time, they get so ground down, so fine, that we get this formula, Si silicon O2, the oxygens. Vinegar, key ingredient in making most of our pickled items. And again, the H's are not combined together, telling us that that H is set off from where the location of the other H's are in this formula. Another name for this one would be acetic acid. Vinegar is what we call it, though, when we buy it at the grocery store. Sugar. This is sucrose, C12H22O11, a little bit different from glucose, which is floating in our body, in our bloodstreams. C6H12O6, this one is a little bit different, sugar. It's got twice as many carbons. Butane, key ingredient in all of your lighters. Hopefully, you don't know anything about this, but it's got a little bit more higher energy. C4 as opposed to the propane heaters. This one has a little bit more energy content, a little bit more heat whenever we ignite it with our flint strips on these lighters, C4H10. All right, last part of today is that we will need to become familiar with the polyatomic ions. Again, look at this list. This is an exhaustive list, and kids had to memorize this previously. I've reneged on that idea. You're still only going to be needing to be familiar. I will warn you, however, you will run out of time if you are not familiar with how these are written. If you did not put the due diligence to become familiar, to make the flashcards that I am giving you the time to do in class, to look through them, you will not have enough time to Google your answers. The idea is that it is available to you, not that you will Google all of your answers. All right, so what is a polyatomic ion? Well, it's different from a molecule, and one of the key ingredients that you will notice about it is that it has charges on it. So now this is a representation of those elements that are combined together. So it shows you the formula written underneath it. So one of the ones that I think is really important that we would know is like a sulfate here. And this sulfate has the formula SO4, but it has a charge, of -2. Notice the location of the charge. The charge tells us that it has gained 2 electrons. It's unstable. It's trying to find someone who it can give those 2 electrons to. It has stolen them from somewhere, gained extra electrons. It has extra electrons, but it doesn't want that. It wants to be at a neutral zero. So it's going to try and look around and find someone it can bond with. So these polyatomics never stand alone. They always are combined with someone else. And later on, we'll figure out how we go about naming it when they combine together. But for right now, I'm just wanting us to get familiar with the idea of writing not only the common molecule names and their formulas, but these polyatomics, their names, their formulas, and their charges. The charges are always in the upper right-hand corner, always, or not always, most of the time they're with negative charges. There are a few times when they have positive charges. So another good one that I would think that you want to know is the carbonate. Carbonate is a CO3 minus 2. Now, the odd thing about this is that if I lose one oxygen, the name changes slightly. It went to sulfite, or we could have carbonite. The same thing is what we would have with chlorate and chlorite. So we have some scenarios where we have to pay attention to the suffixes. Nitrate, nitrite, another fine example. Just one oxygen's difference changes the name of the polyatomic. So don't get lured into the quick and easy answers. Practice, study, be prepared, and we are going to go over this as a quiz, and I will have some practice problems for you in the homework. So this is all that I wish to share with you today about our first topic, getting familiar with the formulas and names of some compounds and their elements. Thank you so much. Have a great day. Bye.